Hello, Robert.
Good afternoon, Dennis.
Yes, we are afternoon. Yeah, welcome here by us about this conversation. So today we're going to be talking about lithium and upgrading, specifically upgrading to lithium. Not as much for new installations, mainly for the people that have an existing system and they think they want to upgrade to lithium. So the old technology, lead acid, and thinking of putting in lithium. And I thought I'll invite you. Maybe you can introduce yourself because you are quite an expert on the subject.
Thanks, Dennis. Thanks for having me. I'm Robert from Powersol. We are designers of electrical systems and suppliers of electrical equipment, and specifically suppliers of lithium batteries and systems into the RV market and various others. And been doing it for many, many years. People are still nervous for lithium, but it's been around for a long, long time in its current shape and form.
Yeah. You're based in Cape Town?
Based in Cape Town. Business been going for about 12 years now. Good business. RV business is growing and has grown from when it started in its basic form, I would say, with old technology to where we are today.
Yeah, I met you about 20 years ago.
I was just thinking about it, but 20 odd years ago. It's the first time we started doing business, yeah.
It's when I started building motorhomes, and you guys were the electric experts at that time. But there was no lithium around then.
No, not back then. No, it was all normal lead acid in its various technologies, gel or AGM or normal lead acid batteries.
I think maybe that's a point. So when we talk about lead acid, we talk about basically all flooded cell batteries. Is that correct?
Well, flooded. So lead acid batteries comes basically in three shapes or three technologies. It's flooded cell. That's the one where you can hear the liquid if you shake the battery. Then you get AGM, which is absorbed glass mat, where the liquid is absorbed into like a fiberglass material in between the lead plates. And then you get gel, where the liquid is really in a gel shape and it changes shape as you charge it. Becomes more liquid as you charge and becomes more solid when you discharge. So that covers lead acid batteries.
Okay.
In its history of many hundreds of years, I would say.
Yeah. Okay, so it's important. And those lead acids, for those different types you mentioned, they all have the same, around about the same characteristics about charging and discharging and how much amps you can take from them. They're all similar. Very similar.
Yes. Very similar. Some depends on manufacturers, but they all roughly discharge to 50%, and they all accept roughly the same sort of charge current percentages. Which is predetermined by the chemistry of the battery, the way it's built, yeah.
And that's why I'm of the opinion that lithium is such a game changer, because what we just mentioned now, the 50% discharge and the charging curves, lithium is completely different.
Very much. It's the way it absorbs and releases energy. And the efficiency in the way it does it. If you take a lead acid battery and let's talk in round numbers, let's say a 100 amp hour battery, which is a very common battery in electrical systems. A lead acid battery can absorb roughly 25 to 50%, depending on which one of the ones you go at. And at 50%, the battery gets hot when you're charging at that rate. Which means it's energy being lost.
All right. So just to put that into real world perspective, 50% charge rate. So if I have a 100 amp hour battery, you're saying it's only going to take 50 amps into the battery?
Into the battery.
It can't take more.
It can't take more.
You're charging.
The chemical reaction doesn't allow for more energy to be absorbed.
So if I put it in these terms, if I charge with 50 amps and the battery is empty, it will take 2 hours to charge. Roundabout.
Give or take, because it tapers down at the end, but yes, roughly. Yeah.
That's also important. That last bit takes a lot more. So to 80% is a quick charge, but that last 20%.
That's correct. 80 to 85% is where the battery absorbs most of its energy.
Yeah.
And that last sort of 15% can take a long time depending what you're charging with.
Yeah, all right.
Yeah.
So, yes, so when you look at lead acid, there is a limit how much you can have the battery to charge.
That's correct.
Yes, so there's, again, remember we're going to compare it to lithium, so which means that the amount of energy that the battery will give is far less than lithium.
About a third less.
A third.
About a third less, yeah. Depending again on the type of lithium battery and how it was manufactured. We'll get into the importance of the manufacturing process of the lithium when we get there.
Yeah. All right. So what I'm just trying to establish is that when we look at lead acid, the reason why you want to go to lithium is the main reasons is how much quicker it will charge, or how much the battery will absorb the energy, how quickly you charge it, and more efficient and easier to charge. But at the same time, the lithium battery will also give you more at any one stage, at any time.
That is correct.
Compared to lead acid.
Lead acid.
So when people want to upgrade, they are finding in their current lead acid setup, they are finding that the moment they get to a battery 50% state of charge, that they really don't have more out of the battery, again, without damaging the battery.
That's correct.
Yeah,
that's correct.
When we used to install lead acids into our motorhomes, we would set up the equipment for our customers not to be able to draw more than 50% of the capacity of the batteries, to protect the batteries, because the moment we would set it up to 60, 70, 80%, the batteries don't last long.
You reduce the lifespan of the battery.
Yes.
That's essentially what happens. And if you expected 5 years out of your battery, you're only going to get 2.5, 3 years, depending on how deep you discharge it. And the shallower the discharge, the longer lifespan you had out of it. Although any battery has got a manufacturing lifespan, and normally says that in the specification sheet. It does mention it there.
Yes, so that's where we're going to get into. Lithium can discharge so much more. I think we set it up to about 85%, I think.
That's so if you were looking at a drop-in type battery, lithium battery, which most people are going to upgrade to, it will actually, you can safely discharge up to 90% out of the battery, so 10% remaining. Comfortably do that without doing any sort of damage to the battery, as long as you stay within the maximum discharge current that the manufacturer recommends. So on the data sheet of the lithium battery, two very important things that you need to look at is the maximum charge current and the maximum discharge current. So if you are used to running, let's say on your motorhome with your lead acid batteries, a air conditioner and a induction oven stove, and it's drawing, let's say, 200 amps, and you go and replace your lead acid battery with one lithium battery, and it's only got a 50 amp maximum discharge rate, it will disconnect the battery from the system because you're trying to discharge too much energy out of it. So it's very important whenever you look at a lithium battery, maximum discharge rate, maximum charge rate. And as you parallel the batteries into a battery bank.
Okay, well, sorry, Robert, we'll get to that. I think we're going to get to that just now.
Okay.
There's advantages and disadvantages. I'm just trying to lay the foundation to go. Yes. Why are we going to go with lithium? And I think, according to my understanding, what I listen to the customers, is purely they need more energy. They need more energy out of the batteries, and the lead acid is so restrictive. Whereas they understand that lithium will give them a lot more, a lot quicker, and you will charge them a lot faster and a lot quicker.
That's correct. So its acceptance rate of a lithium battery is far superior to a lead acid battery, depending on what the manufacturer states. So yes, it does absorb the energy quicker, and it can absorb a lot more energy, depending on what the manufacturer says. there's definitely limitations to it, but the technology allows for rapid charging, rapid discharging, or very long discharge, and weight and space is probably two of the biggest advantages that we find today. Is that yes, the drop-in batteries were specifically designed to take the space of a 100 amp hour lead acid battery, for example, but they are making them smaller and smaller as technology changes. So for the same space, you can have up to double the capacity of your battery bank.
Yeah, weight, big advantage.
Big advantage. Weight, space, speed of discharge, and speed of recharging.
I've heard the term energy density.
That relates directly to the size of the battery.
Yeah.
Yeah, and how
so
much energy.
lithium is more dense than lead acid.
Its energy density is. I remember when lithium was released into our industry in 2008. I did my first system. Most of the manufacturers spoke about the thirds. It was 3 times energy density to a lead acid battery, 3 times the space less, 3 times the absorption rate, but also 3 times the cost.
Yeah.
At that time. It's changed since then. That's changed a lot since then. Yeah.
All right. So I think we pretty much laid the foundation about the advantages for having lithium in the first place.
Well, there's one more advantage we didn't touch, Dennis. Sorry, is lifespan. Lifespan of a lead acid battery. If you discharge to 50%. Is if you really look after your battery well, I would say in today's terms is 5, maximum 7 years out of a lead acid battery. It doesn't make a difference which one of the technologies you go for. Lithium battery sort of starts at 10 years.
This is on 50% now?
No, even most lithium batteries would be at 80% discharge. So 20% remaining will give you that sort of 10-year lifespan out of your battery.
Are there batteries on the market that use new cells, and are there batteries on the market that use used cells?
Yes. They call them, they don't like to use the term used cells, they use a term what they like to call second life.
And do those also have the 10-year lifespan?
No. They have, because they're second life batteries, they've got less cycles. Yeah, so at that point already, I'm not that familiar with all the second life
but they are available in South Africa.
But they are available. I know of a few brands that offer a second life battery and first life brand new cells as well. And that's, brands that are used commonly as replacement batteries.
And would you, if you don't know, would they tell you? If I'm in the market for a battery.
That depends on the salesman.
Let's say I don't go to you.
Yeah.
I don't go to you.
Yeah.
I go to somebody else.
Yeah.
And I go, hey guys, there's a battery. The price looks so good. Is it first life or second life?
I want to say the only time I've ever come across it, someone brought a battery for me to test, and he did not know it was a second life battery until I pointed it out. There was a sticker on the battery that said second life, but the sales guy did not inform him that it was a second life battery. So it depends on the sales guy.
All right. Lifespan, 10 years. Average on new batteries?
On new batteries is average about 10 years, yeah.
If you look after them again. You still have to look after them.
Lithium has got different pros and cons to lead acid batteries that affects its lifespan as well.
All right, so let's go to the disadvantages. What are the disadvantages?
So the biggest one is, depending on the application, is probably temperature. So some of the guys in the off-road market, for example, a lot of the guys install their lead acid battery in the engine compartment, where temperatures can reach 70, 80 degrees Celsius. That's a big no-no for lithium batteries. Lithium cells start deteriorating or lose lifespan, longevity, over 55 degrees Celsius. Most battery manufacturers will give you an operating and a storage temperature, and you'll find that most of them limit you to 55 to 60 degrees Celsius operating temperature. And if you constantly use them, charge and discharge above 55 or 55 and up, you greatly reduce that lifespan. So that's probably the main disadvantage of the actual battery technology. If you're looking at installation-wise, I don't know of many disadvantages there.
But you could put a temperature sensor in your lithium battery that the charging switches off when it's a certain temperature reaches.
You can. Most good reputable charging brands also have a temperature sensor you can put on the battery.
We can say Victron.
Oh, can we?
Not
okay.
a problem.
Okay.
You can say Victron Energy.
So, for example, Victron Energy, most of their battery charger, the bigger batteries, battery chargers, come with a temperature probe. And that temperature probe is supposed to go onto your negative terminal of the battery. And what that does is, it obviously measures the temperature of the battery, but it allows the charger to change its charging characteristic based on the temperature of the battery, which is very important. It'll basically change the voltage that the battery needs at those temperatures, which is very important. But that 55 degrees Celsius actually starts affecting the cells if you operate it in that voltage. In that temperature.
Yeah.
So that's probably the main disadvantage of lithium batteries, is that. Other than that, I can't think of many. I can't really think of many.
One of the ones that I always run into is, for our products, we always need a secondary lead acid because you can't use lithium to start. Still, there are some brands, I believe, that are starting to bring out starting batteries, but they don't like it.
Yeah, you can buy. There's some brands out there that do a specific cranking battery. Very expensive and very limited. And yes, lithium batteries aren't designed to crank. And I wouldn't use it in a vehicle as a cranking battery.
That's what lead acid still has.
That's where lead acid has got that advantage. Yeah. That CCA rating that your engine needs for, and it's high. It's often very high, especially a big diesel motor.
250, 300 amps coming out of those batteries.
Yeah. Even in really big marine applications, the guys don't do it. You're buying a 5 million rand boat. They don't use lithium batteries for cranking. It's just not practical. Not while lead acid batteries are still available.
Yeah.
And at that price.
Yeah.
Yeah.
So putting in a secondary charging cycle circuit is still a lot cheaper than buying lithium for cranking purposes.
Definitely.
Yeah.
And will be for a long time. Lead acid batteries slowly phasing out and will become cheaper and cheaper and cheaper and cheaper. And a cranking battery these days, everyone stocks one. You go to any battery shop, they all have them there. So easy to
stop anywhere
to replace it. Yeah.
So that's one disadvantage that we run into, is that they still can't do that cranking for the vehicles.
Yeah.
So
definitely not. Yeah. I'm trying to think of any other disadvantages of a lithium battery. Well, there is one disadvantage which if the system is not designed correctly, is that lithium batteries all have a BMS, a battery management system, and a lithium battery, and they all vary depending on the manufacturer, have a cut-off voltage. In other words, if it reaches, and it's most often around 10 volts, 10.2, 10.6, below 11, around about there, if you reach that voltage, the battery actually disconnects from the system. So you will have nothing operating at that voltage. Whereas a lead acid battery, for example, at 10 volts, it's flat. It won't run your fridge, or it won't run most products. However, most LED lights, a lot of LED lights are multi-volt, can run down to 9 volts. So you can use a lead acid battery below 12 volts, for example.
For longer, because you can use it for longer because the voltage just slowly
exactly.
And on lithium, you can't go below a certain voltage.
Well, they'll have a disconnect voltage of, let's say, 10.6 volts. They have an operating voltage, some of them, of around 11.2 to 11.6. That's where they want you to operate the battery in.
Yeah.
So if a lithium,
we actually use that as our cutoff point in our systems.
A good system.
Yeah.
That's what you should be using. I would normally say just above their recommendation. If they recommend 11.5, I'd make it 11.6, 11.7 or so. That's a well-designed system. So it gives you that extra layer of protection for your battery, which in the long term adds to its life.
But because you're only going to reach that when you've used 75-80% of the battery, where lead acid you can only go to 50.
That's correct.
It cancels each other out almost.
Pretty much, yeah. That low voltage, that 11.6 volts, you're only going to see that at 98% discharge. It's right at the end when you start seeing those low voltages. So your equipment will run right there, and because the lithium battery its energy density is so high, you can have a smaller battery to get the same sort of running time out of a lead acid battery.
All right, the term drop-in, nice term, and we always get the questions from our customers as well. They sell the drop-in lithium batteries, and there's a misconception out there with that word. It's actually a very bad term.
It is a bad term. So originally, I think the term was used or created or coined as a drop-in replacement for a battery size. So the guys didn't want to go and make a new battery bracket or a new battery box, because the battery can actually now be smaller. Because the energy density, if you buy a 100 amp hour lead acid battery and you buy a 100 amp hour lithium battery, the battery can be a third smaller than a lead acid battery. Yes. So the guys didn't want to go and force the client to build a new battery box. So they made them the same size as a 100 amp hour battery. So take out, drop in. That's where the term stops.
Yes.
That's where
it's basically drop-in was used, the term was coined to go. You can take your lead acid out, and the same modular form, height, width, can go into the same spot.
That's it.
It doesn't mean that you can actually do that without further modifications.
That's correct.
So that's where the term drop-in becomes very dangerous.
That's where it stops.
Yes.
Is where you actually physically drop it in and mount it. Other than that, after that, the drop-in goes away completely, because then that's where your electrical system needs to be modified, adjusted, changed to work with the lithium batteries.
I had a look at the Victron Energy Multiplus. Multiplus is the inverter chargers, which is a product that most customers want. They want a product in the motorhome, which is an inverter and a charger all at once. It's a very easy installation. The equipment is there, and it will look after your batteries if set up correctly. But I took a look at the recommended installation guidelines, and I just want to explain to the listeners that it's immediate visible why we say the drop-in stops it when you actually put the battery in, and everything else changes. So for a Discoverer 4, Discoverer 6, if you think about it, the cables from our lead acid batteries to the 12 volt DB board, the fuse box and all of that, we use 12 square millimeter. So remember, square millimeter. So it's not actually 12 millimeter diameter. It's a term how they sell and categorize wires. It's square millimeter. So we use a 10 square millimeter, which is about how much? What's the diameter of that? It depends on the installation.
If you take diameter wise on a 12 mil square cable, is about 6 to 7 mil, depending on the insulation thickness. But it's about that. It's the surface area that we're referring to, the millimeter square. Yeah.
So for a Discoverer 4 or 6 or any similar unit, from a lead acid to our DB board, 12 volt DB board, we use 10 square millimeter, and from the charger to the lead acid, we use 8 square millimeter. If I look at the Victron Energy Multiplus, the smallest one that probably is within what our customers want is a 2000 watt unit. Well, it's 1600 watt, it's 2000 VA.
Yeah, it's about there.
So that's probably the minimum that our customers will want to power a Snappy Chef, an induction, or run your computer, or run a TV and some sound, or just the minimum that you'll probably put in your motorhome is 2000 watt. The recommended size of cables from the battery to the Multiplus is 70 square millimeter.
That's correct.
So it's 7 times of what we standard put in a Discoverer 4 for lead acid.
That's correct.
Doesn't that show the amount of current, the amount of electricity that these batteries need or can give?
Yeah, it does relate directly to that. Because because of the energy density, they can release all of their energy in one go and absorb, again, depending on the manufacturer, so much more energy than a lead acid can. And in DC, same as in AC, but DC it's a lot more relevant. The thickness of the cable is directly related to the distance that you run the cable at and how much energy you're going to move through that cable over a certain period.
Yeah.
And if you get that wrong, you can have many issues. Fires,
Yes.
the product won't work correctly because you'll have a voltage drop, so your unit will be switching on and off unnecessarily. So it's critical.
Well,
it's
the
critical.
big thing is fire.
That's probably the most
big
important
risk.
thing. That is the biggest risk, yeah. You will lose your vehicle if the
Yeah.
cable is too thin and you're trying to squeeze 100 amps, for example, through a 10 mil square cable.
Because the battery will take it.
It will.
And the lead acid will never take it. That's the difference.
It won't, yeah. Where
Size for size.
Size for size, exactly, yes. And the lithium will try and suck that power through that cable to the point where it becomes a fuse. It'll melt.
Yeah.
Yeah.
Becomes a fire stick.
Very much. Yeah, it's very dangerous. We've seen over the years many installations where the cable size isn't correctly calculated. There's many apps these days that actually helps with that. So if you want to double check it, there's apps like Blue Seas, Victron themselves has a nice app you can use to check cable sizes. And in a really good installation, the cable shouldn't really heat up. Cables these days, most well-manufactured cables allows a temperature of up to about 105 degrees before the insulation becomes dangerous, I would say. Yeah. So
before it starts to smoke.
Yes, and at 105 degrees Celsius on a copper cable is
You'll
very,
start to
very
smell
high.
it.
You would smell it. You would definitely smell it. Yeah. Yeah.
Yeah, well, that's obviously, so that's the first thing that came into my mind when I thought about this subject. And when people contact us and they say they have a motorhome with lead acid, they would upgrade to lithium, do we sell the batteries? And we just go, but it doesn't stop at the batteries.
Yeah.
There's so much that needs to be changed, and we just touched the wire size. That's the only thing we touched so far.
Yeah.
And it shows you the danger you can go into if you don't do it correctly. So it's ultimately recommended by me, and I'm sure by you, that really go to an expert that's done this before.
Definitely.
A proper installation center that will look at your entire system and will find out what needs to be replaced. But the cables needs to be replaced. It's a whole different fusing system.
It's the fusing, it's the configuration of the equipment, because the lithium battery's got a different charging algorithm. So the chargers all have to be set to its lithium programming. And that's every single charger. That's the DC-DC, that's the multi-plus, that's your solar. All of them have to be reconfigured.
All right, so just to put it in terms, so your alternator charging,
that's correct,
is not correct for lithium.
No.
And for lead acid is mainly fine.
Yeah.
Your charger that you probably have in your lead acid battery probably might not even have the right curve for charging a lithium. If you have a slightly older product.
If it's old enough,
So we said DC to DC is now your alternator.
Yeah.
The solar needs to make sure that you can get the right curve for your solar, because you can do damage. If you charge your battery incorrectly, then you get heat buildup.
Well, so the battery is not really going to generate any heat because it absorbs all the energy, but you can give it too much energy, because lithium will absorb more energy than you can actually give it. So you can damage your solar charge controller. You can definitely damage the battery by undercharging it as well. So a lot of people think you can only damage any battery, lead acid or lithium, by overcharging, but you can do the same sort of damage by undercharging. And often the curve for lead acid, the voltage would be higher than most lithiums. And then again, it varies greatly between manufacturers. Yeah. So the reconfiguration of your solar, your DC-DC coming from the alternator, and specifically your AC charger, your multi-plus, or whether you have a standalone battery charger where you've plugged the vehicle into shore power and you're going to be leaving it there for a long period, it's critical to have that configured correctly, because that's where I see most of the damage gets done, because the vehicle is used, parked. Yeah.
There's a lot of currents flowing through these cables, so the protection has to be completely different to lead acid. So there's a lot that needs to be, so we started it with the word drop-in.
Yeah.
So I think with this topic or this part of the discussion, it's shown that drop-in is not drop-in. It really is a whole different system design needed for you to go to lithium.
Very much. It's a new tech. Well, new. It's not so new anymore. It's a different technology. Very different. And changing, I think, is wise to change because it's a far superior product and technology to lead acid. But it's definitely needs to be done by someone that actually has experience. You can go to your auto electrician down the road that's maybe been around there for 20 years, but he's never touched a lithium battery. If he's never touched one, I wouldn't go to someone like that. Try and find a reputable installer that has had experience with installing lithium batteries and changing systems specifically for a drop-in battery.
Right, then we are getting more and more towards 24 volt as well. So everything from now until now, I'm talking now since we started building motorhomes, has been 12 volt. 12 volt on the vehicle, some bigger trucks with 24 volt, but then we will step down to 12 volt for the house. And we are now starting to change our perception a bit, and we've started to introduce 24 volt in our production line.
Definitely required.
Big advantage.
Yeah.
Big advantage. The more power I see, the more power the customers want. We step down to 24 volt and the cables become thinner, the fusing becomes easier.
And also the way energy moves at a higher voltage is better. And because lithium can release so much energy, a higher voltage, up to 24 volts in automotive applications, is critical. Well, no, critical is maybe not the right word to use. It's the right way to go. It's good practice that if you are going to go for, let's say, a 3 kilowatt or a 5 kilowatt system, if you've done the load calculations and the guy's got an aircon, massive aircon that he wants to run the whole night, it's going to draw a lot of energy out of that battery for a long period. It's not practical doing it over 12 volts. Your cable size, because it's such a long run, is going to have to be very thick. That guideline that Victron gives there, 0 to 70, if 5 meters.
That's 0 to 5 meters. Yes.
Yeah, 0 to 5 meters, which is 70 mil square. If you're going to the next level, that they might not show it there, but you have to calculate then that distance.
No. But
and
it does
then
show,
go to a thicker cable.
It does show for 24 volt on 2000 watt, it drops down to 35 square millimeter.
That's it. Because the higher the voltage, the lower the current
so it's
can go
half.
through. Yeah.
It's exactly half the cable size.
Yeah. So you save on weight when you and then
and
that
the cable itself.
And the cable itself at cost.
Yes.
And that just takes you back to the drop-in. If you're going to 24 volts, if your system is growing at the same time and you decide to go to 24 volts, you can reduce the cable size. If you already have 70 mil square cable, for example, you can leave it in there. It has other disadvantage of going over the size, but definitely 24 volt in high energy applications is by far the best way to go.
Potentially safer? Because it's less current?
It's less current. If the system's designed correctly, I wouldn't necessarily go safer. And then again, that's where it comes to your installer. If the installer has never worked, like you just said, in your industry, and certainly across the auto electrical industry in South Africa, where the guys are working on, let's say, caravans, 4x4 vehicles, motorhomes, that sort of stuff, those guys have never touched 24 volts. So the installation does change, but it's pretty much the same as 12 volts.
Slightly different equipment.
Slightly different equipment, and most equipment these days are available in 24 volts. Your pressure pumps are available in 24 volts. A lot of LED lighting is multi-volt, sort of 9 to 30 volts or
fridges,
so.
Fridges are 9 to 36 or something like that.
Yeah. So changing to 24 volts is not complicated. It's not complicated. It's been done in various industries for many years.
I believe it's the future.
Definitely. It's going to happen that most vehicles will, the bigger trucks, will all be 24 volts cranking. And then running their systems from there will be 24 volts.
But in our industry, I think...
Definitely.
I don't know, Marine probably already, they've got 48 volt systems as well. But I think in the motorhome, I think 24 volt is the next standard.
Well, the guys are all looking for more products
yes.
that they have at home. So he gets home and he puts his aircon when he gets home, and he's running, like you say, his little Snappy Chef induction cooker, and his internet's going, and the kids are watching TV and playing PlayStation, all in the motorhome.
Yeah.
And to get the energy, 24 volt is by far the better way to go.
Yeah.
And again, battery-wise, so to get 24 volts on a standard 12 volt, either lead acid or lithium battery, you have to connect them in series to give you the 24 volts. But the advantage with lithium...
Well, you don't need always series. We can buy now 24 volt. One particular battery,
which is 24 volts.
The internal cells will be hooked up to 24 volts.
That's correct. They series and parallel them in a way so that it's 24 volt. That's correct. What I was getting to. So now you don't have to have two batteries. So again, you save by putting in a single 24 volt battery, or 2 or 3, depending how much energy you need to run your system. But that's probably one of the main advantages for going to 24 volt, is that space saving. Instead of seriesing the batteries, you can buy a 24 volt battery.
How much kilowatt is too much? And why I say that? why I say that? We generally, so this is battery capacity. We generally put in between 400 to 600 amp hours.
Yes.
That works out to?
Well, roughly times 12 or so, or times...
So you're probably looking at 5 kilowatt.
That's about average.
Call it 4.5, 5 kilowatt is an average that we put in a motorhome. We did one last year with 15 kilowatts.
Yeah.
How much is too much?
If you're asking a salesman, nothing is too much.
Yes.
Whatever you want, we'll put in there, sir. But I would say the actual vehicle and the system will tell you when it's too much. So if you have a existing system with solar, alternator charging, and AC charging through a multi-plus or a standard AC charger, and you only want to change to lithium without replacing all of that equipment, that'll tell you what's your highest, because you can only take out so much energy out of the battery. Again, depending on what the manufacturer says the maximum discharge is, and then putting back the energy into that battery.
I think that's
the key.
Putting back is the key. I can switch an aircon on, run it for 10 hours. I can take out very quickly all that energy. But putting it back, does the vehicle allow you to put the energy back? No. What you've taken out. And I think that's when you say the vehicle will tell you.
Yeah, definitely.
Because if you're going to use an alternator charging at 60 to 90 amps, and you've got 15 kilowatts of battery, and you're going to be driving for 10 hours, 11 hours, and then you're not even fully charged yet.
And that just when you say driving that far, trying to recharge the battery, if you do not have a current limiting device in between the alternator and the battery, like a DC-DC charger, there must be various other current limiting devices that I'm not aware about, you will burn that alternator out before you fully charge that battery, because that battery will absorb all the energy you can give it, and it will burn out. And again, same as even if you do get to shore power and you have a 20 amp battery charger or a 30 amp battery charger, and you've got 15 kilowatts to recharge because you've been running your aircons for hours and hours and hours, it's going to take you many hours to recharge it. So that is the biggest thing that most people forget about, is putting the energy back. So too big, when is it too much?
When you can't charge it anymore.
When you can't charge it anymore. And solar, a lot of people are going, solar's the way. Solar's definitely the way to go. But you're limited with roof space.
But not in our industry.
No.
Our industry, solar is a drop in the ocean.
It's really, because what can you fit onto a vehicle? Maybe 2 solar panels. You've got your aircon on the top, maybe a fan. 800
to 850 watt. We battle to get 1,000 watt on the roof.
So that really limits you. Really limits you to recharging the battery. Your primary source of charging in a vehicle, obviously, because you're running, is your alternator.
Yes.
So if you're doing a long trip, you want to take as much energy safely as possible out of that alternator to keep it into the battery. And that's where you have to focus on your DC-DC charging. Maybe upgrading the alternator to a high output alternator is one of the ways to go. And again, taking care of the cabling in between, making sure it's the right sizes. Very, very important that guys forget about when they upgrade stuff.
What we've done before, and we've developed a kit for a secondary alternator, specifically for the Iveco Daily 4x4.
Yeah.
where we add an additional high output alternator. They come in 12 volt, 24 volt.
As well. Even 48, if you're ever going to go to 48 volt installations, yeah.
And you can pump, and on 12 volt system, you can pump 200 and 220 amps into your batteries, compared to 60 to 80 of your standard alternator.
Yeah,
so it's a massive increase.
It's a big advantage going that way. And because the battery can accept it, it will charge that much faster.
Yeah.
So a lithium battery, if you're buying a really good quality lithium battery with a high charge absorption rate, and I'll take the Victron Energy Lithium 100 amp hour super pack battery, for example. It's a 100 amp hour battery. It can take 100 amps in charge. So in other words, a 1-to-1 charge. So you can recharge that battery from flat to full in 1 hour. That's how fast you can charge it.
If you give it 100 amps. Yeah.
If you give it 100 amps. Yeah. If it's a 100 amp hour battery and it can only absorb 50 amps, it'll take you 2 hours to charge, sort of thing, depending on the size of the battery.
That's quick.
So it's phenomenal. It's changed the game of recharging completely. But you still need to have that charger to charge it.
Yeah.
Solar is not going to do it on a vehicle. The next thing would be your primary charge, which is your alternator. You could also add a little AC generator if you want to in the vehicle.
Yeah,
to run the multipliers.
Correct. You put it 10 meters away and you start it, you run it. But what is that it's going to give you?
You haven't got the space to put a big 10 kilowatt generator on a vehicle. So it's not commonly used these days, I would say.
2,500 watts to 3,000 watts is something that people sometimes take with.
You run a small charger off that.
Yeah.
It's going to take you forever. You're going to run it for hours to charge a 15 kilowatt battery bank.
So charging through the alternator, or obviously on the campsite.
Of course, yes.
If you're on road and you are on a campsite and there's power available, if you have, for example, the 3,000 watt multiplus in it, you can charge to 120 amps.
That's correct.
So we limit that to 100.
Yeah.
We actually
That's a good way
to limit it. Programming,
yeah.
and we go. Then you can get 100 amps out of that charger.
So in theory, with a 100 amp battery, you charge it in an hour.
Yes, but if you're driving, and you can even do it more, because the high output alternator, the secondary alternator, can give more than the multiplus.
That's it. Yeah. No, it's definitely a route to go. I know the marine industry, secondary alternators are commonly used there for recharging the house battery.
Right. We spoke about a lot. So where can the listeners go for more information? We covered a lot of points.
There's a lot. Look, there's lots of information online. A lot of it is driven by the manufacturers of the products. Victron Energy is where I would direct you. First of all, they've got a fantastic website. If you go onto their website, they have their website split into various markets. And if you're in the RV market, click on there, it'll give you lots of information. They also have an online platform called the Victron Community. You register, and there you can ask any question, Victron related. And there's people all over the world, Victron employees, technicians that work with Victron and various other products that answers 24 hours a day.
Yeah, so you can Google Victron Energy, you'll get there. Or Victron Energy Community.
You get there, all the information's on there. You can ask any question, you can follow people. It's a fantastic platform for information. And then a reputable reseller.
There's other brands, yes.
That's going to tell you that it's a second life battery without asking.
Yeah. So there's a lot of information online. Most of it's probably correct, but might not be applicable to your specific installation. So take it with a pinch of salt. And that's why we say go to the experts, because you might read something online and that would point you in a certain direction, and it's completely wrong for your particular application.
Definitely. It's always application based, and it's potentially very dangerous. Too thin a cable. You're going to expect X amount of lifespan out of your battery. If you undercharge it, you're going to get less. If you overcharge it, you're going to get less. If you run it at too high a temperature, and something I didn't touch on was too low a temperature on lithium batteries, also dangerous. So below 5 degrees Celsius is sort of the industry standard, I would say. So below 5 degrees Celsius, you can discharge a lithium battery, but you can't recharge a battery below 5 degrees Celsius.
So how does that work in Scandinavia when you have an EV?
So a lot of battery manufacturers now include a heating pad in the battery. So at the bottom of the battery, they'll put a little heating pad, and that draws energy off the battery. But it's a low energy heating pad. They heat it. Yeah. So it's you will reduce your battery life. In fact, it's dangerous to run the battery, to recharge it below 5 degrees Celsius. If you read most data sheets, they will tell you there, do not recharge or do not even use below 5 degrees Celsius. Look, in our country,
now we don't have an issue.
Easily going to have that problem.
But I do have customers. I have customers out there that do go below 5 degrees.
Yeah. Well, if you go to
but
the city,
mainly the motorhomes. So lithium, another beauty and advantage that we didn't even speak about lithium, you can install it inside. There's no gassing.
Oh, of course, yes. There's no gassing, which makes it very, very safe.
Yeah. And difficult to go below 5 degrees.
Definitely,
for a motorhome.
For a motorhome, definitely in South Africa. But it's something to keep in mind when you're traveling through high altitudes like Lesotho, for example. I had a client running through there the other day, and he had to put in and what he did in the end was he bought a little snake eating pad for that you go to a pet shop.
Yeah.
And he just installed the batteries on top of that, and off he went.
Yeah.
And he's had no problems. But he didn't reach -5. So. But definitely, there's lithium batteries. It's the way to go. If you're considering it, I would highly recommend it. Find the right product, right installer, speak to your installer, and make sure he's supplying the right products. And he's able to modify your system for the battery.
Yeah.
Yeah.
That's probably something we have to mention as well, is that we just talking and having a conversation about scraping. We're just scraping the top of it.
Oh yeah.
We are not going in depth here.
No.
So whatever we say, it's not an installation manual. So guys, you need to really, everybody, you just need to think. We would highly recommend going to an expert to do any changes from lead acid to lithium. There's many pitfalls that you can get into.
Definitely.
Robert, I think we've done it. Thank you very much.
It's a pleasure. Thanks for having me, Dennis. That was a good conversation. I think it's needed. It's overdue. It's definitely overdue.
Yeah. So let's hope we can reach the listeners out there and that they like it. And if there are loads of questions coming out of this, then I will definitely...
we can do a follow-up.
Push your button, we do a follow-up, and we answer all those questions that
For sure,
the listeners have.
Yeah.
Right, Robert, thanks very much.
Thank you, Dennis.